Hello and welcome to the 8th video that I'll be posting on my Java tutorial series. And in today's video, we are going to talk about and summarize all the topics that we have discussed in the arrays video. With that said, let's start by opening up our Visual Studio Code. And in this video, I am going to focus more on the dimensional arrays and how to create them, as well as how to create 3-dimensional arrays, 4-dimensional arrays, and so on. And once this is open, we can start and make a new file and name it array summary. So let me click on the new file and name this array summary.java. And then inside of it, we have the public class, just usual. And then we need to type in our code, which is the public static void in line 2 here. So I'm going to type in public static void main string args, and as usual, this code is used to run everything. And the first thing that I will explain in this video is how the 3 or 4 or even higher dimensional arrays look like. And actually, to do that, I don't actually need to use the Visual Studio Code, but rather this Jamboard right here. And this is a 3-dimensional array that you can see. And since we know from the previous video that the 2-dimensional arrays are arrays that store arrays in them, the 3-dimensional arrays will look somewhat similar to the 2-dimensional array. And the different thing is, instead of storing 1-dimensional array, the 3-dimensional array will hold 2-dimensional arrays in them, as you can see here. Let me just get my pen here. This is a 2-dimensional array and a 2-dimensional array. And this is found in a 3-dimensional array. And with that said, as you can see, the array itself is storing 2-dimensional arrays. Now, with that said, let's figure out how to create an array with higher dimension arrays. Well, when you think of it, you can actually find a pattern. In a 2-dimensional array, it stores an array. If it's a 3-dimensional array, it stores a 2-dimensional array inside of it. Which means that when you want to create a 5-dimensional array, the array itself will be holding 4-dimensional array. So a rule that we have to remember is, in array any dimension, the array that they are holding is 1 less than them. As you can see, in 3-dimensional array, it holds 2-dimensional arrays inside of it. So you can imagine it as, 1-dimensional array below it for which it holds. And I guess that simplifies how we are dealing with arrays. So if it's a 6-dimensional array, then of course the array that it is holding is the 5-dimensional array. And in this case, if it's a 3-dimensional array, it will be holding 2-dimensional arrays. And inside of 2-dimensional arrays, it will hold the array, and array itself is just a block. Okay. And with that said, we can actually start to learn on how to create an array. Well, whether or not you actually know it, but to create an array, let me just comment this. Array creation. We usually type in this line of code here. The data type, we have the square brackets, and then we have the name of data type equals new, sorry, not name of data type, name of array equals to new data type, and then we have the square brackets. And this is our normal line of code to create an array, a 1-dimensional array. But as you can see here in the 2-dimensional array, we have 2 square brackets. And if you see this pattern right here, we actually can know that depending on the dimensional array, you have to have the same amount or equivalent amount of square brackets. Meaning that if you have 3-dimensional array, then there is 3 square brackets. And if you have a 4-dimensional array, well, you guessed it, you have to have 4 square brackets. So this is a 3-dimensional array with 3 brackets, and then if it's a 4-dimensional array, then we have 4 square brackets. If it's 5, then you have to have 5 square brackets. And I hope that cleared things up. And then, how to predefine values inside of array? Well, predefining value is pretty much the same thing as creating, where we have to just essentially type in the name of array, and then we have the square brackets. Depending on the length or the dimensional array, you have to have the equivalent amount of square brackets and then just put in the value. And the value must correspond with the data type as what I have mentioned in the one-dimensional array. And the unique thing that I'm going to explain more about is probably this length right here. As you can see here, there is the length, and then there's another length that we have to account for, and another length, and another length, and another length. And to simplify from what I have in the Jamboard, let's just make this into a three-dimensional array. And we have the length of array, length of array, and length of array. And you might be wondering, what does this length actually stand for? Well, this length stands for the first box, or the length of the array 3D. And we can imagine it as the first index, or the amount of two-dimensional arrays that you want to hold. And in this case, of course, the length will be 2 because there is two 2D arrays, right? Or let me just type it down here. We actually have two 2D arrays, which means that the array 3D will have a length of 2. And then inside of the second value here, let me just replace this with 2. Inside of this bracket right here, we have to account for the 2D arrays and the length of the 2D arrays. As you can see, there is 3 data because there's 3 arrays that the 2D array can hold. So we have to remember that's 3. And then we look at the array, and the array itself has a length of 10 because there is 10 data. So we can just type in 10. And to simplify, if we have, 4-dimensional arrays, 5-dimensional arrays, 6-dimensional arrays, 7-dimensional arrays, or maybe more, we have to look at the first length, and that length will be the number of data that the said dimensional array will hold. And then you have to look at the array and what dimension is it in. Is it a 4-dimensional array? Is it a 3-dimensional array? And then you have to look at the length inside of that again and again until you fill in the last square bracket, which is going to tell us the number of data that the array is holding, the one-dimensional array is holding. And I hope that simplifies. So if you're having trouble with creating, this right here, usually you can always, draw it first, visualize how many data you really need, how many blocks are you going to need, and how many divisions do you want. And that usually helps solve things because you get to know how many, aspects or how many elements that you have to store, and then you can create the array 3D or array or create the dimensional array. And then from there you can create the dimensional array. Okay? And accessing is also something that you have to learn. And let me just type it down here. So this is predefine values, and then we have the access value. So let me just type it down. Access values. And whenever we want to access a value, we just need to remember this right here, where we have to always refer to the name of the array, and depending on the dimensional array, you have to have the equivalent number of square brackets, and each of these square brackets will have their respective indexes, which you have to remember. And in this case, if we have a 3-dimensional array, then we have to have 3 square brackets, right? Because there is 3-dimensional arrays. And since we have the 3-dimensional arrays, we have 3 square brackets, and each of these brackets will have their indexes. And the first index will decide whether or not we want to take the first section or the second 2D array. And then from there, for instance, if I want to take 0, and then we want to take in the 2D array, the 0 2D array, and then we want to take in the first array, the first index array, and then I want to take in the data from that first index array, which is 4. So we get to print out 204. And that is how it will work. And if you're having trouble with this, once again, I advise you to draw it or have a picture in your brain on how many data you want to store and how is it organized. that is accessing value. So just remember, depending on the dimension array, you have to have the respective square brackets and their indexes. Now, printing an array can be done with two methods, the normal method and the library method. And the library method requires the import of java.util, which is import java.util.asterisk. And the asterisk here means that we are importing everything. And despite, the dimensional arrays, you don't really need to think about it because the library method will always be system.out.println print line arrays deep to string for all dimensional arrays except one dimensional array where we use toString. So despite you have a 10-dimensional array, 9-dimensional arrays, 8-dimensional arrays, it doesn't matter. You need to use deep to string, but for one-dimensional array, you need to use arrays toString, and that's unique to one-dimensional arrays. But other than one-dimensional arrays or arrays itself, you have to use deep to string. And I just want to clarify that. That is the library method. And then we have the normal method. And the normal method, as I've shown you in the two-dimensional array, makes use of the for loop. And the way we do this, or the way we have to remember, is that in a dimensional array, remember that the dot length keyword here, length keyword, is different from one another. As you can see here, if I were to say array 3d dot length, which is the length of this right here, then we get 2 because we have two 2D arrays, right? Which is why we can use this to have 2, or get a value which is 2, and then we have this right here, the two-dimensional array, and we can always refer to that by saying array 3D and then referring to the index of it and dot length. And by doing that, the compiler already knows we are referring to this two-dimensional array, and it looks for the length of that, which is 0, 1, 2, meaning that there is 3 arrays or one-dimensional array. And actually, let me just use the text to write it much better. 3 arrays, and then from there we can use the array 3D, and we can take in 0, and we can take another index to refer to the array itself, right? Because there's 3 arrays, but we want to know the length of the array. So we can take in another index and then dot length again, and we get 10 because there is 10 data. And as you can see here, there is 3 different values of length inside of a 3-dimensional array. And this applies for almost all, where when it's a 4-dimensional array, then there is 4 different values of length. And if it's a 5-dimensional array, then there is 5 different values of length. And all of this can actually be used inside of the normal method. And for the 3-dimensional array, let me just type it down here. For int I equals 0, I is always less than array 3d dot length. And by doing that, we can actually check it one by one and print out this value or this array 2d first, and then this array 2d. And inside the array 2d, we have to have another for loop. So let me just type it down first. We have the usual for int I, and then we can have another one which is for int I2. And whether or not you know this, but you have to have different name for the for loop if you are having another for inside of a for loop. As you can see here, there's a for loop, and then inside of it, I have to use a different value for the I2 or the I. I can't just say for int I again because it will detect this as overriding value, and you don't want to go and have problems like that. So it's not good to have problems like that. So yeah, just never have the same name inside of the same for loop, or I just advise having different names for the variable inside of for loop every time because it just helps understanding the code overall. So we have for int I2 and then I3 array 3d I2 dot length. Let me just type it down first and I'll explain to you what this all means. Okay, and then we have the system.out.println array 3D I2 and I3. And this is for the 3D array. And as you can see here, we take in the array 3.length, which is giving us 2 because there is 2 data in this case, of course. And then we have the array 3D I, which takes in the index from here. And since the value from the first I is always equals to 0 or 1, because it runs 2 times, which means that the value it's going to take is the array 2D length. And as we know, the array 2D length, or annotated with array 3D index, is 3. So this will always give us the I2 will never be greater than 3. And this one should tell us I2 is greater than 2. And then array 3D I2 gets the array, and it means that the I3 can never be greater than 10. And as you can see here, we make use of all these length value inside of the for loops, which allows us to actually print it out one by one. And the example here is array 3D, starting from I is 0, and then I2 is 0 as well. And then we have 0 for I3, and then I3 condition right here, which is 0 is less than 10 is true, becomes 1, 2, 3, 4, 5, up until 10, and 10 is no longer false, or 10 is never greater than 10 itself, so it's false. And then that value becomes 0 again, and then I2 becomes 1, and this repeats until 3, and then 3, 10, and then 3 is never greater than 3 itself, meaning that array 3D will get 1. And then 1, 0, 1, 0, 1. That means 1, 0, 1. And actually, we have to start with 0. And then we have 1, 0, 1, 1, 0, 2, 1, 3, until 10. And that repeats up until all of the values printed out. So essentially, you have to make use of the length keyword whenever printing out the array. And I hope that cleared things up. And don't worry, in most cases, you're just going to face two-dimensional array, which I have covered. But this is a rare case where we are going to, meet 3D arrays. And the logic is not that different from the two-dimensional array and one-dimensional array. So just make use of the for loops and the length value, and then that's it. And then we have the overriding and replacing algorithm, which is not so different. So let me just copy paste from the two-dimensional array so you can see how it looks like and how it compares. Switching method, we have the two-dimensional array, and the three-dimensional array is not much different. As you can see here, we just make use of this right here, and the only main difference, let me just delete that because that is causing a lot of error. Okay, and the only main difference here is that instead of making use of 2 indexes, we need to make use of 3. So if array 2D I2 I3 is equal to, let's say it's 1 to 3, then we just need to system.out.println I plus I2 I3. And that's just it, because we need to print out 3 indexes because there is 3 index, and we just have to refer to the 3 index whenever we are searching. And that's the difference between the 3-dimensional array with 2-dimensional array. And if we are dealing with higher dimensional array, then you just need to follow the brackets, the amount of brackets, square brackets of course, and the indexes, and that's it. And also you have to modify a bit of the normal method, which is the for loop. But other than that, of course, you're pretty much done. And next to that, you have the overriding method, and the overriding method is pretty much similar as well. And the only main difference between that is in overriding method. Let me just copy from the two-dimensional array again for you guys to compare. Actually, let me just tab that one and then print it out. And I'm going to enter this and type in overriding method. The only main difference is, yet again, we are referring to the 3 indexes, and we are just going to, instead of printing out, we are just going to overwrite the array 2D with the I2, I3, and the new value. So yeah, there is no difference between the algorithms. It's just we have a additional for loop here, and the reason why we have this additional for loop here is because we are dealing with 3-dimensional arrays, and if there's 4-dimensional arrays, then it's most likely you are going to use 4 for loops. And yeah, also, before I actually want to continue, I need to also try and explain that yesterday I think I failed to mention that we can use a break here. And the break here is just to stop the operation earlier before continuing. And there is 30 data that this algorithm is searching for, right? And 30 data is a lot to search. And if it already finds the data and overwrites the value, then why not just break it so that it stops the operation at the same time? And I normally do this whenever we want to change a value, but I guess I'll be discussing this further on and in the next few series, because I'll be explaining deeper about the searching as well as sorting arrays in the next couple of videos, which are going to be much more advanced than this right here. So yeah, for the meantime, I should have used break here because this right here just stops the operation earlier on. But I would have thought that if there's multiple values of 204 and you want to actually change all of them to 240, then we need to use or delete that break, because the break directly, once it's activated, it stops the for loop and that's it. So yeah, but for the meantime, that is all that I want to talk about. And then also take note that when you break this right here, if I say break here, then the break will apply for this for loop right here, where it stops its for loop and then it directly checks the next I. And it's much more effective this way if there is only, let's say in this 2D array right here, if we want to do this, we have the for loop that's checking this, this, and this, and another for loop checking this, right? So if there is multiple values of 204 inside of this value here, 204 for instance, or let me just edit this. Give me a second. What happened if we, for instance, say this is 204 and there's not 204 and this is 204, and we all want to replace all of this into 240, then we can use break here, because once we find the value of array inside of the index 0, then it directly stops it and directly goes to 1. And yeah, it's much more effective that way rather than searching all of it. But you don't really have to focus on that right now, because it's pretty much going to be discovered and pretty much going to be talked about in the next series. So yeah, for now, this is how it works, and you don't really need to remember the use of the break for now. And I'm just going to specify it just in case. So you don't really need to focus more on the break right now, and I'm just trying to indicate why I use break just now there. Anyway, I think that sums up today's video. I know that today's video will be short because I'm basically just recapping all the information from previous videos. However, this is my opinion, just additional information that I want to clarify just in case you guys ever want to create a higher dimensional array. And I think that sums up today's video, and now we're going to just revise everything. And the first thing we're going to revise is array creation, where every time you want to create an array, you have to have the equivalent amount of square brackets. If you have a 5-dimensional array, then you have to have 5 square brackets, and each of the square brackets have length in them. And remember, or just visualize these lengths as the value of the number of data they can hold. So inside of array 3D, the first length value will indicate the amount of 2D arrays that I can hold, and then the second length value will always indicate the length of the 2D arrays, and then the final length is indicating the number of data that the array can hold. And yeah, just imagine it going from step by step. So it breaks down the problem from array 3D, which is 3-dimensional array. We have to specify the length of the array 3D, and then we specify the length of the array 2D, and then we specify the length of array. And I hope that simplifies things. And then we predefine values, and the predefined values is just the name of the array and the equivalent brackets, each with their indexes. I forgot to type in indexes, so there we go. It's just the name of the array, index, 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 value, and that's it. And accessing values, just the same thing. It's just the name of array, index, index, index. And remember that the square brackets and the indexes must be equivalent to the dimensional array. And I hope that makes things clear. And the printing out uses system.out.println, and then arrays deep to string, and arrays deep to string is accessible to all dimensional arrays except one-dimensional array, where one-dimensional array uses array.toString. And remember that for this to work, you need to use the import java.util.*. And then the unique thing that I want you guys to remember is that each and every length keyword in dimensional arrays have different values. So if it's a 4-dimensional array, then there is 4 different length values that you can get. If it's a 3-dimensional array, then there is 3 length values that we can get. And as you can see here, in an array 3D, we have the array 3D.length, which is 2, array 3D with index 0.length is 3, and array 3D index 0.length is equal to 10. And that's because array 3D has 3 layers. As you can see, there's the first layer where it holds the 2D arrays, and then there is the second layer where there is the arrays that are held inside of the 2D array, and then we have the final layer where we can access the data from inside of the arrays, which is why there's 3 layers that we have to account for, which is why we have to have 3 indexes, and each and every length keyword have their respective uses. And I think that's it. And in normal cases, to print out the normal method, you have to use all of the length keywords. And if there's 4-dimensional arrays, then there's 4 unique length keywords, which means that there is 4 for loops. And if there is a 5-dimensional array, then there is 5 length keyword or length values, which are unique from one another. And that means that there is 5 for loops that are used in order to print out using the normal method. And for the searching method, there's nothing different from the 2D or arrays 2D or 2-dimensional arrays, and they just make use of the normal method, which has 3 for loops, and instead of having or accessing it through 2 indexes, array 3D needs 3 indexes, and that's it. And overriding method also applies the same treatment, where you need to have 3 for loops, and the value can only be accessed through 3 indexes. And I think that sums up today's video. Thank you for watching. I hope that I can provide you with sufficient information for arrays, and in the next video, I will get deeper into programming the algorithm for searching and even sorting data inside of arrays. But for now, thank you for watching, and I'll see you in the next video.